Hi, in this lecture we are going to discuss about the flyweight design pattern. The objective of this short lecture is to understand the flyweight pattern and to study two case studies. First, we are going to talk about symbols in Faro, and the second one is colors, so how we can use flyweight in the case of color. So what is the objective of the flyweight pattern? So the intent, if you read the book, is to use sharing to support a large number of fine-grained objects efficiently. So what does it mean? Is that sometimes we are going to create a lot of objects that are similar, for example, characters. So in the character 1 and the character 2, and we're going to reuse them all over. So why to create many different characters when we can actually reuse them? Because the character 1 is going to be always the same kind of object. So the flyweight pattern will actually tell us to create, for example, a map where we are going to store or cache those well-known objects to be able to only create them once, store them, and reuse them. So at the end, it's actually just a cache. Let's see an example with the symbol instances in Faro. So what is a symbol in Faro? A symbol is like a string. It will behave as a string. So we are going to be able to concatenate symbols and so on, but they will be unique. So in that sense, we are going to be able to compare symbols using the identity operator. So two symbols, regardless of when and how they were created, if they have the same number of characters and the same characters, they will be identical. So that means that the system is going to ensure that when creating a symbol, we are going to reuse the same symbol that existed before. One of the objectives of reusing symbols is that we are going to reuse memory footprint. So instead of allocating a lot of different symbols that actually have the same value, we are going to reuse them when they have the same value. So in this case, when we are going to use symbols, we can be sure that they are referring to the same object. So that is what this piece of code ensures. So how does it work in the case of Faro? So if we check how symbols are created, there is in the symbol class, there is a method that is intern. So that takes as parameter a string or a symbol. What this method is going to do is to check if this string or symbol is already in the internal flyweight implementation. And if it is not there, it will create a corresponding symbol and install it in the table. So first we check if that symbol or string is already internal. If it is not there, we're going to add it into the table. Now, the symbol implementation here is a symbol, it's an implementation of the flyweight pattern that will create new objects dynamically. So we don't know all the potential symbols that we are going to use beforehand. So that is why we need to, every time that we need a new symbol, we need to be able to support the creation and addition of new symbols in the table, in internal table. A separate case study is the case of colors. So for example, in Faro, we have the UI theme class that represents the themes. So for example, the dark theme or the light theme, and you can change how Faro looks like. And the UI theme is going to actually create a lot of colors. So it will, for example, the dark theme is going to create a lot of colors in the dark with dark nuance, or the light theme, it will create whiter or similar colors. We have solarized themes that will be more yellowish and so on. And every time that we are going to paint something in the screen, we are going to use a lot of colors. So the question is, do we create thousands of similar colors or not? And so if we look at the code of UI theme, we see, for example, we have this kind of methods, so background color and text color, that say, okay, I'm going to use the color white as the background color, and I'm going to use the color black as a text color. So this is, for example, the case of a default theme that will be white. The question that we can ask ourselves is, should we turn color into a flyweight? Because if we see the code as we had it before, we have background color that is returning color white. So is this method color white always returning a new color, or it's going to reuse the same white color? So The thing that we should take into account to decide if we should intern an object or not is first the cost of interning it. So how expensive would it be to add it to a table or to hash this object to look for it in an efficient way? Also, one thing to see is that, for example, in this case, having a flyweight will save us from allocating a lot of different objects that represent the same value, but it will not save us from having a lot of requests. So if we have here our flyweight that has our white color and our red color, still we could have a client. So this one will have one of each, but the client can make maybe thousands of requests. So here, if we make a flyweight for colors, we are not solving the cause of the problem, which is actually a client that is requesting thousands of times for the same object. So we need to check if actually the cost in the execution time comes from actually allocating objects here or from actually a bad client that is making a bad number of requests. Also, some other questions that we could ask ourselves. So do we need to create always different colors dynamically, or the number of colors will be fixed statically? In that case, for example, we could think about a table of fixed colors that we can reuse. Or otherwise, we need to think about a system like in the symbols that will be able to grow dynamically and where we are going to be able to add new colors dynamically. The other thing that actually is super important is that we are going to be able to cache objects that are value objects. So objects do not need to change or need to be immutable once in the flyweight. Otherwise, if we are going to be able to mutate the white object and turn it into a green object, then all the users of the white object will suddenly be a green object, which will be a string. So we are going to use a flyweight to be able to return colors to a client without creating them endlessly. So that means that the flyweight will save us from allocating objects. So it will have less allocations. We could implement a flyweight as, for example, a palette of colors, which at the end is just a cache at the level of the domain. So we are going to provide a domain object that is, for example, a palette of colors that will somehow manage two things at the same time. First, provide a domain representation for something that is useful, for example, a palette of objects that has different colors for a particular usage, like, for example, the UI theme. And at the same time, it will serve as a cache to avoid allocation. So the flyweight is at the end just a case of a domain cache. So what are the possible limitations of such a palette implementation? First, we can think about implicit colors. So here, for example, we can compare color red darker against self-selected background color. So here what we see on the left piece of code is that we have a color red that, if implemented as a flyweight, it will return as always the same red color. However, when we are asking darker to that color, that will create new objects, new darker colors every time. So darker is a message that, given a color, it will return a new color that is slightly different from the receiver. So here it will return a darker red. We need to take care that our darker methods or our modification methods also go through the flyweight in order to respect the pattern. Otherwise, the darker methods are not under our control. And then we are going to have the same problem as before, but now these methods are escaping the flyweight. Another thing is that just saying color red darker all over our code is not actually representing the domain problem. So instead, we could have, for example, a method selected background color, as in here, that will return a color red darker, but it will also give us a point of interception where we will be able to cache the color that we are creating. Now we have to really take care of this, because patterns like this could be useful, so creating colors as such, but they could be a bad design practice when used wrongly. As a conclusion, you can implement a flyweight pattern to be sure that you have unique objects and that you are limiting the memory footprint of the creation of such objects. Be careful that the flyweight will help you to limit memory footprint, but it will not help you to reduce the number of requests made to that flyweight. So be careful that you need to better fix the cause than the consequences sometimes. So sometimes you will need to, for example, profile your application to understand when the problem is in the allocation of objects or in the client of those allocations.